Sandhya from the Department of Botany, Maharani Science College for Women, Mysore. A very warm welcome for this class today. The topic of today's discussion is structure of a typical anatropous ovule and the different types of ovules. This comes under the reproductive biology syllabus for second year BSc, 4th sem CBCS students, the practical syllabus of Mysore University.
Now, before learning about the ovule, we have to see the position of the ovule in the flower. This is LS of flower to show the position of the ovule. In the central part of the flower is the female reproductive structure, namely the pistil or gynoecium, which is made up of carpels. So, the pistil or gynoecium has a basal bulbous ovary, a slender style and a terminal receptive stigma. In this basal vase-like ovary, there are many ovules, one to many ovules. Ovule of an angiosperm is technically called the Megasporangium as it encloses the megaspores. It is a diploid body and enclosed within the ovary wall attached to the carpel wall by the placenta. Majority of angiosperms show anatropous type of ovule where the funiculus or the stalk of the ovule and the micropyle or the opening of the ovule lie side by side. So generally it is called as an inverted ovule.
Now this is an inverted ovule, or it is also called as anatropous ovule or bent ovule. So the ovule has got the following different parts. There is a stalk called as funicle or funiculus, which is attached to the body proper of the ovule. So the junction between the stalk and the body proper of the ovule is called as hilum. Major part of the body of the ovule is made up of a nutritive tissue called as nucellus, a diploid nutritive tissue called as nucellus. Covering the nucellus are two protective coverings called as integuments, outer integument and the inner integument. The integuments surround the nucellus on all sides except for one part where they leave a small opening to the ovule called as micropyle. Then there is a structure called raphe, which is the continuation of the stalk of the ovule towards one side of the body of the ovule. In the nucellus develops the female gametophyte or the embryo sac. Technically it is called as embryo sac. The embryo sac has got a group of 3 cells towards the micropylar end, a group of 3 cells towards the chalazal end and 2 nuclei in the center called as polar nuclei. The rear end of the ovule, which is a little bit swollen, is called as the chalaza or the chalazal end. So the group of 3 cells towards the micropyle are called as egg apparatus, in which there are 2 pear-shaped cyanogytes, and then there is a central spherical egg cell, which is also the female gamete. In the center there are 2 polar nuclei, which later on fuse to form a single nucleus called as secondary nucleus. Towards the chalazal end of the embryo sac, there are a group of 3 cells which are called as antipodals or antipodal cells.
Now, there are 6 types of ovules in angiosperms. The most common type is the anatropous ovule or the bent ovule, which I spoke about till now. The anatropous ovule, in this type, the body of the ovule becomes completely inverted during the development such that the micropyle and the funicle or the stalk lie side by side. So the ovule takes a 180-degree turn, a bend, 180-degree bend. So this is the most common type seen in angiosperms. Majority of the angiosperms, 80% of the angiosperms have this type of ovule, the anatropous ovule or the inverted ovule. Example, gamopetalae members. Then coming to the orthotropous ovule, this is called as the straight ovule, orthotropous ovule or atropous ovule. The body of the ovule is erect and straight such that the funiculus, the chalaza and the micropyle all lie in the same straight line. Example, polygonum in angiosperms, and all gymnosperms have such type of ovules. Hemianatropous type of ovule. or hemitropous type of ovule. The body of the ovule is placed transversely at right angles to the funicle or the stalk. The micropyle and chalaza lie in one straight line. So it takes a 90-degree turn. Example, ranunculus. Next is Campylotropous ovule. In Campylotropous ovule, the body of the ovule is curved and bent round so that the micropyle and the chalaza do not lie in the same straight line. The ovule takes a roughly 90-degree turn, but the micropyle is facing downwards. And this such a type of ovule, the embryo sac will also be slightly bent. So this is seen in Leguminosae members or the family Fabaceae. Then coming to Amphitropous ovule. The curvature of the ovule here is so much pronounced that the embryo sac also becomes curved. So the ovule is curved like a horseshoe shape, and also the embryo sac inside is also curved like a horseshoe shape. Bent embryo sac. So this is seen in Butomaceae, Alice Macy, etc. Then lastly coming to Cercinotropous ovule. Remember CIRC, circle, Cercinotropous. So the funicle here is especially long that it creates a nearly full circle around the ovule. The ovule takes a 360-degree turn. So the micropyle ultimately points upwards. So it takes a 360-degree turn or more than 360-degree bend. The stalk of the ovule becomes too long because of more growth towards one side, rapid growth towards one side. The funicle or the stalk becomes extremely long. So these are the types of ovules. The ovule after fertilization develops into the seed. So seed is also called as a post-fertilized ovule. Thank you.